Hello. Hello, everyone. I'll just share the slide. Okay. Uh, wait. Just know I might have to quit and reopen. Give me a sec, okay?
Yeah, sure, Gauri.
Okay. Hello. Hello, all. Can you see my presentation? Is it visible?
Yes, Gauri. It is visible along with the knots.
Okay. Cool. Maybe I just turn off the notes then. Okay. Give me a sec. Okay. So, good evening, everybody. Um, I'm Gauri. Ijishnu already introduced me. So, I'm working as a postdoctoral fellow in Institute of Earth Science, Academia Sinica, Taiwan. So, today I'll be giving you a talk about the corals, which are the hidden treasures beneath the blue, and why are they important. And I'll be also sharing some insights into the major threats they are facing and uh, some of the conservation methods that we can choose to protect these fragile ecosystems. Okay, so I hope you all are familiar with corals. So, what are corals? Are they plants or animals? So, basically, corals are marine animals which are coming under the phylum Nidaria. So, they are basically made up of each building blocks called polyps. Here you can see in the figure, this is the polyp. This is a single organism. So, like this, many polyps together build the coral structure. So here you can see the coral structure. The corals have a tubular polyp structure with tentacles, which they use to capture food, and they have a mouth and gastrovascular cavity. And beneath the polyp, they secrete the calcium carbonate exoskeleton. So by secreting this calcium carbonate exoskeleton, they actually basically builds the reef structures, huge reef structures. And this is not something happens in few months or days. It's a long process to build a whole reef. Like it takes millions of years or to build a big huge coral reefs that actually existing now. And actually we can see whatever we are seeing now is have been forming from a long before. So yeah, there are mainly different types of corals, like mainly two types of corals, which is hard coral, which is commonly known as scleractinians. They are basically contributing the reef formation. So basically they are known as the reef building corals, and they secrete the calcium carbonate exoskeleton. So here in the right side upper figure, you can see the Acropora species, which is one of a hard coral. And then comes the soft corals, which does not have a calcium carbonate skeleton, and they are flexible and they do not form the reefs. And the example is the lithophyton species, which is presented in the right bottom corner. And again, the corals actually can be seen as a solitary or as colonial. So here, the Acropora species are known as colonial species because they form a colony of polyps. So millions of polyps will be staying together as a colony, and they form the reef structures. But there are some corals who can actually live solitary and build the calcium carbonate skeleton, which is mushroom coral is an example for. So here you can see in the left side is the mushroom coral, which is known as the solitary coral, which alone it only has a single polyp, and that single polyp is actually creating the calcium carbonate structure. So in another way, we can also divide the corals into zooxanthellate corals and azooxanthellate corals. So what is zooxanthellae? Do you know about zooxanthellae? Basically, zooxanthellae are the symbiotic algae which are present or living within the coral tissues. So coral and the zooxanthellae is having a symbiotic relationship where the zooxanthellae or the symbiodinum or the microalgae is providing nutrients for the corals, while in return the corals are giving shelter and protection or a home for the algae to survive. Okay, and so those corals which are bearing zooxanthellae are called the zooxanthellate corals. And basically most of the all reef building corals are zooxanthellate corals, which are having a symbiotic relationship with the these microalgae. And there are other corals which does not have any zooxanthellae, and those corals are known as azooxanthellate corals. Okay, so they don't have the microalgal symbionts within them. So how do they survive, or how do they get the food? So basically corals get nutrients from the zooxanthellae, and also the corals can actually capture the organic matter which is suspended in the seawater using their tentacles. So the zooxanthellate corals, most of them are relying only on the organic particles which is suspended in the water column, and also they capture sometimes zooplanktons or some phytoplanktons which is floating in the ocean using their tentacles, and that's how they feed on. And yeah, so basically there are two different types of corals, which are zooxanthellate and azooxanthellate, based on the algal symbionts. So what is coral reefs? What are coral reefs? So basically they are the underwater structures which is made by the polyps, right? The coral polyps make the calcium carbonate skeleton. In with time, in by time, it creates the huge reef structure which provides the shelter for many marine organisms. So they can be found in the shallow and warm tropical regions, and they are known to be home for more than around 25% of the marine life. So this is an example of a picture of the coral reef, how it looks like. It's very vibrant, colorful, and we can see different varieties of corals present in the coral reefs, right? Okay, so basically there are different kinds of coral reefs. The major three coral reefs types are the fringing reef, barrier reef, and atoll. So what is a fringing reef? So the first picture is showing a fringing reef. Here you can see it is a continuation of the shoreline, right? There is no lagoons or any shallow water regions between the reef edge and the shoreline. So they directly develop along the shoreline, and mostly common. They are the most common and simplest type of reefs, and they have very narrow lagoons, or they don't have lagoons at all in some of the reefs. And the examples of fringing reefs in India are the coral reefs in the Gulf of Mannar, and also the reefs in the Andaman and Nicobar Islands are known to be fringing reefs. And the next type is the barrier reef. So here, as you can see in the picture, the barrier reef is having a shallow lagoon kind of structure between the coastline and the edge of the reef. And they are seen parallel across the shoreline, and they are very large and continuous. And one of the major example for the barrier reefs are the Great Barrier Reefs, which are seen in the Australia, which is the biggest reef in the world. And also another example is Belize Barrier Reef, which is found in the Central America. Okay, and then comes the um, atoll. So they are actually ring-shaped reefs with a central lagoon. So there is no land in the center, just like in the barrier and the fringing reefs. There is no land between the reef edges in the center. So it is actually formed by the subsidence of the volcanic island. So before there was a volcanic island present, and it got subsided with time, and that region where the volcanic island was present became a lagoon. So basically the atoll is a circular or annual ring kind of um, a reef with a central lagoon, which is could be deep or maybe shallow. And one of the major example are the reefs in Maldives, and the Lakshadweep reefs are also known to be atoll reefs. Okay, so these are the major different types of reefs: barrier reefs, fringing reefs, and atolls. Eh, I'm sorry, it's not changing. The slides are not changing. Eh, Okay, so this map shows the distribution of coral reefs across the world. Here you can see the red dots are representing the warm water coral reefs, and the blue dots are representing the cold water coral reefs. So what we see in our region are the warm water coral because we are in the tropical region. Okay, so the warm water corals are basically found in Indo-Pacific, Caribbean, and Red Sea regions. Basically, they are tropical, present in tropical and subtropical seas where the corals can get plenty of sunlight. So they will be shallow. They will be in the shallower region at a depth of 0 to 60-meter depth where there is plenty of sunlight are present. And some examples for the warm water corals are Acropora, Poecilopora, and Poritus, which are very common corals which is found in our coastal regions or our coral reefs. And then comes the cold water corals, which are basically present in the North Atlantic, Southern Ocean, and they are present in the deeper oceans, deeper regions of the oceans, which are they can be also known as mesophotic corals, which can be present at a depth of more than 100 meters, and they can be seen in both polar and temperate oceans. They'll be in the darker, deeper regions of the ocean, and some of the examples are Lophelia and Madrepora. Okay, so why corals are important? What are their functions, or why are we behind conserving these ecosystems? So basically, coral reefs are nurseries for millions of, or homes for many marine organisms, nurseries for many commercially important fishes and other invertebrate species, right? Even though they only cover less than 1% of the ocean floor, they are home for millions of fishes and invertebrates, and most of the species are yet to be discovered. Actually, there are so many species which are not known, like we need to discover them. And moreover this, they are obviously they are one of the most productive and diverse ecosystems. Moreover this, they also provide some ecosystem functions for the humans, which includes food and fishing, because many one more than 1 billion people are depending on the coral reef fisheries for the source of protein and as their income. And also for medicine, there are so many marine organisms which are living in the coral reefs who produces some certain metabolites which are used by the scientists to produce drugs, also for cancer treatments and different other treatments. And also another ecosystem function is that the tourism, because of the stunning beauty of coral reef, there are millions of people who comes to visit the coral reefs for diving, snorkeling, and other purposes, for aesthetic purposes, which actually helps the economy of the many coastal villages. And there are so many people who are basically relying on this tourism uh, generated from the coral reefs. And another important function of corals are the coastal protection. So they actually acts as a wall between the open ocean and the coastal lines by protecting the coastline from the storm surges and big waves such as tsunamis and all. So they actually protects our coastal areas, just like the mangroves. Mangroves also having the similar function of protecting the coastlines from the damages caused by the storms and all. And overall, coral reefs actually provides nearly 400 billion a year to millions of people in economic goods and ecosystem services. And this is why coral reefs are important. And moreover, all these economic or tourism purpose or whatever the ecosystem services that they provide, they are very much important for maintaining the balance of the ocean ecosystems. If they are not there, everything is gone. Basically nothing will be in balance. So they are really important for the ocean chemistry, ocean circulation, whatever it is. Like, they are very important, and if they are gone, everything is gone, and even it will affect the land and the human beings as well. So yeah, that's why we are uh, focusing more on the conservation of coral reefs. So what are the major threats that they face? So basically climate change is one of the major threat that coral reefs are facing now. So the due to the human activities, like such as burning of fossil fuels or industrialization, using the fertilizers and deforestation, etc., is causing the emission of greenhouse gases, right, which is eventually resulting in climate change. So what happens when these human activities are happening? So basically more carbon dioxide is produced and more carbon dioxide is released into the atmosphere, right? So what happens to the carbon dioxide in the atmosphere? What is the role of ocean in or removing this carbon dioxide? Basically, ocean, the seawater acts as a sink for the atmospheric carbon dioxide. It absorbs all the carbon dioxide present in the atmosphere, and this actually uh, resulting in changes in the ocean. Excuse me, 1 minute. Okay. So what happens is the ocean absorbs the carbon dioxide, okay, which is resulting in ocean warming, which is causing the thermal stress for the corals. And then the increased temperature in the atmosphere is resulting in melting the ice in the polar regions, which is eventually causing the sea level rise, which could increase the sedimentation, which eventually smothers the corals to death. And then changes in storm patterns, which brings stronger and more frequent storms, could actually physically damage the corals. Basically the branching corals and all, they are very vulnerable to the physical damages caused by the storms. And then changes in the precipitation. When there is more rain, there will be more freshwater influx to the ocean, which will bring the toxic pollutants, fertilizers, which are all present in the land to the ocean, which will eventually cause damages to the coastal habitats, including the coral reefs as well. And then the altered ocean currents, which actually changes the connectivity and temperature regimes in the coastal regions, which could actually affect the larval dispersion of the corals and bringing of the nutrients. Everything will be changed. And finally the ocean acidification, which is caused due to higher absorption of carbon dioxide into the ocean water, which reduces the ocean pH, and it pose a threat in the solution of the calcium carbonate skeletons of the corals. So what can we do, basically, as human beings or a responsible person, to reduce the carbon footprint? We can use more, as we all know, it's a basic thing. What can we do actually? We can drive less, like less use of automobiles. We can reduce, reuse, or recycle the plastics or whatever we are using, and we can purchase energy efficient appliances and light bulbs, and then we can print less, download more, use less water. And these are the things that we can do to reduce the carbon print, which will eventually have a huge impact on the climate and the oceanic changes. And for helping the coral reefs, we can reduce the use of fertilizers, we can reduce the use of sunscreens. Sunscreens are one of the major, like we all know nowadays people are behind sunscreens, like they're crazy about sunscreens. They think they protect, the sunscreen protect us from the UV radiations and all, but recent studies have shown it's the opposite. They don't have much effect on, or they don't have much impact on the sunlight which is falling on our skin. And yeah, these sunscreen are eventually ending up in the ocean, and that is having a huge what huge that causes a huge damage to the coral reefs. And also we can choose sustainable seafood, and learn about good reef etiquette and practice when we are in the water. Like when we go for snorkeling or diving, try not to touch the corals, try not to destroy them with our fins and all. I don't know whether you people have tried ever visiting coral reefs by diving or snorkeling. So if you ever plan to go for a snorkeling or diving trip, be cautious, not to use sunscreen, don't get panic, or just don't use your fins, or don't step on the corals, or don't touch the corals or break the corals. Breaking and collecting corals are illegal in our place, so don't do that, and be a responsible diver. And also you can actually volunteer for beach cleanups and waterway cleanups, like the river cleanups, etc., because all these pollutants which are present in the water, the chemicals, or I mean the plastics, all are eventually going to the ocean. So better help cleaning them and all. That is what we can do to help our coral reefs. So okay. So this is one of the important thing majority of the scientists are studying now, which is the impact caused by the thermal stress or the global warming, and due to the heat waves and all. So here you can see is the coral bleaching, which is one of the important thing which is studied by the scientist. So here in the picture you can see the first picture is of a healthy coral, and the second picture shows a bleached coral. You can see the white corals. The healthy corals look colorful, but the bleached corals looks white. And eventually, if the coral bleaching prolongs, like if there is a prolonged exposure to the oceanic higher temperatures, that will eventually result in the coral death. So bleached corals doesn't mean they are dead, but if it is prolonging, the condition is prolonging, then the corals will be dead. So what is coral bleaching? Why corals become white? So as we all as I said earlier, the zooxanthellae, right, the microalgae present in the coral gives actually the pigments for which is seen in the corals. Actually this coral gets colorful because of the presence of the symbiotic algae. So what happens when the temperature increases? So basically, what is happening is once the temperature or there is a thermal stress, the coral is expelling their microalgae within their tissues into the water. So that leaving them white. Later, it becomes white because they are leaving all the zooxanthellae present in their tissue. So why are they doing this? What is the mechanism behind the bleaching? Why are they releasing all their source of energy, or the primary producers which are present in them? This is because when there is an intense temperature and light exposure, the photosystems of the microalgae actually gets disrupted. When this system gets disrupted, they will not produce energy which is efficient for the corals. Instead, they will produce more oxygen radicals which are toxic to the corals. So this oxygen radicals become more toxic, and that could damage the DNA or protein and lipids present in the coral tissue. So in order to avoid this damage, the corals, what will they do? They will expel the microalgae. If the microalgae is present, then only the toxicity will happen. So in order to avoid the toxicity, they will expel all the microalgae, leading them to be bleached or white in color. And if the condition, or if the light intensity of the or the temperature impact is prolonging, that will eventually lead to the death of the coral, because they do not get any nutrients, because microalgae is providing the nutrients for the zooxanthellae corals. If there are no zooxanthellae, they don't have any nutrients, so eventually the corals will die. So if the bleaching event is like reduced, or the heat or light intensity gets reduced, that time the corals can actually regain these zooxanthellae from the water, and they can be again healthy. But if the condition prolongs, they will be dead. So this is the major impact of thermal stress. And it's not just only caused due to the thermal stress, even changes in salinity, ocean acidification, and other factors are also like combined, coupled with the thermal stress to cause the coral bleaching. Okay. Now comes the impact of ocean acidification. So as we said earlier, the anthropogenic activities such as burning of fossil fuels, or reef deforestation, or the use of industrial things actually releases more carbon dioxide into the atmosphere. So what happens to the atmospheric carbon dioxide? The ocean actually absorbs the excess atmospheric carbon dioxide, and this carbon dioxide combines with the seawater to form the carbonic acid, which is H2CO3. So later the carbonic acid actually dissociates into H plus and bicarbonate ions. Then what happens? The free H plus ions present in the seawater combines with the free carbonate ions in the ocean to form more bicarbonate ions. So in this process, basically what happens is when there is more carbon dioxide absorbed, more carbonic acid is formed, more carbonic acid will be dissociate into H plus and bicarbonate ions. So this H plus ions, when there are more H plus ions, they will all combine with the free carbonate ions which are present in the ocean. So the carbonate ions are very important for the marine calcifiers to form their bicarbonate exoskeletons. So the skeleton, what they are forming is by absorbing the carbonate ions and the calcium ions in the ocean. So when there are no carbonate ions, what will happen? No calcification will happen because carbonate ions are important. So what happens is when the pH is reduced, there will be less carbonate ions and there will be no calcification happening. And the equilibrium between the calcification and dissociation of calcium carbonate skeleton is disrupted. So what happens is calcification won't be there, but more dissolution will be happening. That means coral skeleton or the entire coral reef structures will dissolve eventually if the pH is continuously reducing like this pace. So this is what is happening when the ocean acidification is happening. Okay. Now, what are the other threats for coral reefs other than the climate change? Like the directly human induced threats are, one of the threat is overfishing. Like coral reef fishes are significant food source for over a billion of people around the world, and many coastal and island communities actually depend on the coral reef fisheries for their economic, social, and cultural benefits. But whatever we do, if we do it too much, obviously it will deplete and eventually it will affect the ecosystem health, right? So obviously when we catch the fishes which are in the nursery regions, like the small fishes, what happens, the entire population will decline if we catches the small fishes like juvenile fish catching is resulting in the depletion of the fish population, which eventually will affect the ecosystem health. And then using indiscriminate fishing, where you wanted to catch one fish, but you use such a gear that you will get whatever is coming in the way, that is also causing a impact on the ecosystem health. So use of non-selective gears like nets and traps often actually removes the herbivorous fish. Why herbivorous fish are important in coral reefs? Actually, what they do is they control the overgrowth of macroalgae in the coral reef ecosystem. So they feed on the macroalgae. Hence, they are herbivores. Obviously, they are eating in the plants. So they will be feeding on the the macroalgae which is present in the coral reefs. So once the herbivorous fishes are completely taken from the reefs, what happens? There are no predators for the macroalgae. So there will be more macroalgae than corals, and there will be a competition between the macroalgae and corals for the space and the available nutrients in the water. So eventually the macroalgae will succeed and the corals will be dead. So that will affect the community shift in the coral reefs from coral dominant to macroalgae dominant condition. So indiscriminate fishing is also causing a major threat to the coral reefs. And another important factor is the lost gears or traps which are present in the corals reefs, or even in the open water, whatever it is, like the ghost nets and the ghost traps, etc., are actually causing physical damages to the coral reefs. As well as we know, the ghost fishing and the ghost nets and all are causing serious injuries for the marine mammals as well, right? So this is also an important thing that is affecting the coral reef because of the human beings. So basically what we can do is we can educate ourselves on the local fishing rules and regulations, and we can educate our coastal communities, like the fishing communities, what they can do to avoid this overfishing and all, how they can fish responsibly. And we can also be responsible in terms of make sustainable food choices and only catch what we want. We whatever we get, like using the bycatch reducing reduction devices and all, we can actually reduce catching what we don't want, only target on what we need and leave rest of them in the ocean itself. And also be responsible aquarium owner. If you all have any aquarium in future, if you decide to start a marine aquarium, be responsible regarding what you are getting. Don't take everything from the ocean and keep in your aquarium, etc. And know where your fish come from, and do not release any unwanted fish into the wild. And one of the major example is the lionfish. Well, lionfish, which is a predatory thing, which is obviously it's a invasive species in our waters. Once it is released, they don't have any predators. They will eat up all the destroy all the other fishes in our ocean, and they will compete with them. They will succeed eventually because they does not have any predators. So we should be responsible of what we release into the ocean as well. And other land-based source pollutions are here, like the sewage, untreated sewage systems, the chemicals and the sunscreens that we use for in our daily purpose, and the coastal development, the development of construction sites or the buildings, the development of roads, etc., are actually causing whatever we do on land, we think there won't be any effect on the ocean, like it will end up in land. But no, whatever we do on the land is eventually going to the ocean. And so that will have a huge impact on the ocean, such as the use of oils and chemical spills, road construction, use of agriculture, because the fertilizers used in the agricultural land is during the rain, it will go into the rivers, which is eventually ending up in the ocean itself or the coastal waters. So it will bring pollution, sedimentation, toxins and pathogens into the water, and there will be increased nutrients, which will eventually cause the algal blooms, which can actually affect the coral reef health. So whatever we do in the land will eventually end up in the ocean. So we should be more responsible what we are doing on the land. So how can we help? So reduce fertilizer and pesticides use. Pick up your pets after they do their potty and all. Just remove it instantly. Don't let it stay there, or don't let it run off to the water. And wash your car on your lawns, dispose lawn clippings in composite pile, and harvest rooftop rainwater through rain barrels or rain gardens. Do not dump paint, oil, antifreeze, debris, or other household chemicals into the street gutters or the storm drains, and clean up the spilled brake fluid, oil, grease, and antifreeze. Maintain proper septic systems like the sewage functions with inspections and pump outs every 3 to 5 years. And seek shade after 10 a.m. and 2 p.m. Do not apply sunscreens, or if you want to apply with less harmful chemicals or the coral reef friendly sunscreens. There are recently some companies are producing the sunscreens which are actually not harmful for the coral. So try to use those kinds of sunscreens, and overall reduce use of fertilizers and chemicals, which will eventually go and end up in the ocean. Yeah. So solutions for the restoring or conserving the corals. So what can we do, or what are already being done? So restoration is the science and practice of rebuilding self-sustaining corals reefs to provide fish habitat, recreation, and protection for coastlines. Addressing the threats of climate change impacts, land-based sources of pollution, and overfishing increases the success of coral reef restoration. And maintaining coral reef habitat by protecting the herbivores and controlling the invasive species increases the chance of coral larval settling and becoming part of the reefs. So what we can do is reduce the overfishing, and do not introduce any invasive species into the ocean, or if there are already introduced ones, try to remove them. One of the example, as I told earlier, is lionfish, which are plenty in our coastal waters. So if possible, try removing them from the ocean if you know how to do it, obviously. Then increasing the genetic diversity is another key for producing self-resilient corals, which will be resilient to further diseases or the climate change scenarios. So scientists are trying to make sexually reproduce the corals which have better traits, which can actually be self-resilient to climate changes and all. And I could say one of the coral which I have been studied during my PhD is one of the best example for a self-resilient coral, but unfortunately it itself is an invasive species. It's known as Tubrastria or orange cup coral, which is very widely distributed in the Caribbean and all. So basically, they are known to be an invasive species, but they are extremely resilient. I should say they can be seen in uh, high temperature waters. They don't need to be in a reef environment. They can grow anywhere, literally. So they are actually invasive, and they actually compete with the local corals, but they are extremely resilient. So they can be actually taken as a model species for later how to increase the resilience of coral genetically. They can be used. So yeah, genetic diversity is something that scientists are focusing on right now. And also reducing the impact to corals from vessels, groundings, and anchor reduces the need for restoration. Like try to reduce the physical damages that we are causing to the corals, like using the anchors from the vessels. Actually, when we put the anchor, it go hit on the corals, and it actually causing physical damages to the corals, which will be very hard to restore later, because it takes years to form a coral reef. So if we reduce these damages, we can protect our corals. And also uh, like we can make the nurseries and restoration setups for the corals, where we culture the corals in the controlled setup and later we outplant them into the open ocean, is also increasing the chance of survival of the corals in the future. So what we can do, as we explained in the previous slides, we can choose sustainable seafood, recycle our fishing lines and nets which we use, reduce, reuse, and recycle the use of plastics, use less fertilizers and pesticides, do not dump household chemicals into the storm drains, and use energy efficient appliances and light bulbs, and drive less. These are the basic thing. Being a responsible human being, we can do is these things. We cannot all of us cannot go into the ocean and try to restore the corals, right? So what we can do within our limits are these things. So these following these things could have a huge impact on the marine ecosystem and the coral reefs. So trust me, doing this, you will also contribute to the conservation of the corals and all other marine organisms or the marine habitats. So yeah, and other important restoration efforts are like creating the marine protected areas, assisted evolution and selective breeding for heat resistant corals, coral cryopreservation and genetic banking, artificial reefs and 3D printed substrates, citizen science or coral reef monitoring apps. Basically, what we can do is we can educate the more people about the importance of the coral reefs or the marine habitats, or whatever is happening they are facing, like the climate change impacts, the declining of the coral reefs around the more than 50% of the world coral reefs have already been destroyed because of the climate change as well as the human activity. So we need to conserve rest of the 50%. For that, we all are responsible. We all have to do something. So what we can do is we can make aware the people about the importance of the corals or importance of the marine habitat, and how can we be responsible. We can just actually give them more idea. So these are the things that we can do, and the people are already being doing. It's not what we can do, it's not in the future, it's already, it's people, scientists and other NGOs like ECHO and all is doing it already. Like we are giving awareness to the people already. So Yeah. So this is an example of a revived coral reef. This is completely got dead in the 2015. This they started the coral nurseries. Like here you can see they are doing the restoration things in 2017, and by 2018 it got a big replenished or um, uh, recreated reefs. It's all healthy and happy coral reefs by 2018. So it is possible to bring them back, but we have to be responsible to do so. Okay, thank you. So if you have any questions, you're welcome. Please ask. That's it. Any questions, guys?
Okay, thank you, Dr. Gauri. So now we can open the session for the question and answers. If the students have any questions, then they can open their mic and ask, or they can chat or text that in the chat box, so I can read that loud for Dr. Gauri. Okay. And along with that, she is a IPCC fellow, and as you know, it is one of the prestigious fellowships around the globe, and only 10 people per year will get it, and she is one of those. So if you have to know more about the IPCC, then you can ask about that as well. Please use this golden opportunity to interact with Dr. Gauri. Okay.
Okay, basically the IPCC fellowship is for PhD and postdoc students. So you have to be in abroad somewhere. Actually, they are giving the scholarship to the students from the developing and least developed countries, and you have to be a student in an abroad university. You cannot be in India when if you have to apply for IPCC fellowship. And it's not just 10 people across the globe. They'll select around 30 students. So when I applied, I was the only person who got from Taiwan, and there were other two Indians as well. So they were across the globe, like in different places, but you should be somewhere abroad. You cannot apply it when you are in India. Yeah, but if you need any guidance, you can ask me for sure.
Oh, okay, thank you, Gauri. But I think in the IPCC website, I have seen only
Mm-hmm.
10 to 15 people's now a list at that year, 2020 to 2024 or 2021 to 2023, right? That year, I have seen all,
21 to 23. Yeah,
yeah,
because
they
okay,
didn't
there are
add,
actually
yeah,
no, 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 no. There are actually three different
categories.
organizations, like no,
Oh,
the fund givers, like what we call the
oh, okay,
uh
the funders,
yeah,
maybe
yeah, yeah, yeah.
US's Morocco
Yeah.
Foundation, right?
Yeah,
Morocco,
minus no, Prince Albert Monaco
Monaco, yeah,
Foundation. Yeah,
Monaco
though
Foundation.
they only took around 10 students, I guess, and there were other two fund giving organizations. So they also took some students. There, while I applied when I got there were around 30 students who got the fellowship.
Fellowships, yes. And
Yeah,
anyway, yearly more than 300, 400 people will apply for this fellowship.
yeah, yeah.
Yeah,
Obviously.
yeah, yeah.
This, I think this time after I got, there were more applicants
Mm,
later years, and
yeah,
it's a bit competitive to get
yeah,
because more applicants are coming, right? Yeah.
yes. And it should be directly related to the climate change and
Yeah.
yeah, climate
It
change.
should not be only like it's not like you'll only get if you're doing work in marine things. It's nothing like that. There were people who are from the like the lawyers and all who were having researches regarding the social science, like the social science part of the sustainability and climate change. They were also there. Like it's not necessary that you should be from the marine field. You are from any field, but regarding your working with the climate change, you can apply.
Okay, and the students, any questions? Anyone? Any doubts? So, anyone? If you have any doubts, then we can continue the session for 10 more minutes. Otherwise, we can wind up for today. Yeah. if anyone needs Gauri's contact, the mail ID, then maybe she can provide that to reach out in the future. Okay.
Yours.
Okay, Dr. Gavri, I think there is no questions from the students yet, so we can wind up our session. And
Okay.
I would like to express my sincere gratitude, and you accepted our invitations and give your valuable time, around 1 hour, to give a insights on the coral reef, and give a brief idea and the future perspective, and what we can do in the future with the coral reef and coral reef research and its significance has been discussed. Thank you so much for sharing the new things. Okay, thank you. Yeah,
Welcome. Thank
yeah,
you. Thank you
yeah,
for inviting me. I'm really happy to
yeah.
share what I know. Yeah.
Okay.
Thank you
Uh,
so much.
yeah, thank you. And next week we have another session, and it will be related to the remote sensing and how we can measure the remote sensing by using the pollution. Okay. And for the Indians, tomorrow it will be my sessions, and everyone will join, please. Okay. Thank you.
Okay. Jishnu, someone asked my contact. Could you please give him?
Yes. Yeah. Here's our intern. I can give you
Okay.
a Gmail ID with your permission.
Okay. Okay. Okay.
Okay.
Cool. Yeah.
Personal or
Thank you. Bye-bye.
institutional?
Personal Gmail is okay.
Oh, okay. Thank you. Thank
Okay.
you. Thank you.
Thank you. Bye.